In this example, we want to find the angle theta in degrees given the right triangle. And we notice that there's a relationship between the sides and the angles given by cosine of theta is equal to 8 divided by 9. We can rewrite this using arc cosine as theta is equal to cosine inverse of 8 divided by 9. Now plugging cosine inverse of 8 divided by 9 into a calculator, we'll get that this is approximately equal to 0.4758. Now since trig functions have an input value of radians, the output of inverse trig functions is also in radians. So we need to convert this into degrees. So we'll multiply this by 180 degrees divided by pi. And after multiplying this, we should get that this is approximately 27.27 degrees. Now we want to find all the angles between 0 and 180 degrees, satisfying the equation sine theta is equal to 1 divided by 4. So let's go ahead and just use some logic real fast and realize two things. Number one, the range of sine theta goes between -1 to 1, which means that as our graph is traveling between 0 and 1, because this is continuous function, we'll hit some value of 1/4. And this is going to happen in the interval between 0 and pi divided by 2. And then as we travel from our y value of -1 back, our y value of 1 back down to 0, again, since our graph is continuous, we'll hit a y value of 1/4, and this occurs between the interval pi divided by 2 and pi. So the solution to this equation should be at least two different solutions. Using our inverse trig function, we can rewrite this as theta is equal to arc sine of 1/4. Again, let's go ahead and recall that the domain of arc sine is between -1 and 1, and the range of arc sine is between -pi divided by 2 and pi divided by 2. Therefore, the theta value that we get from evaluating arc sine at 1/4 should be between 0 and 90 degrees. Let's go ahead and use a calculator to compute this. And what we get is that arc sine evaluated at 1/4 is approximately equal to the following. Now, converting this into a degrees measure, we multiply this by 180 degrees divided by pi. Again, we're approximately going to get that this is going to be 14.47 degrees. So the triangle with the opposite side of length 1/4 and whose hypotenuse is 1 has an acute angle theta here, given by this yellow angle, 14.47 degrees. Then again, by symmetry, we know sine theta is going to have another angle in the second quadrant. When we evaluate sine theta at that angle, we get 1/4, and to find that angle, again, we can just go ahead and form a right triangle whose side has length 1/4, or the sides opposite of our angle. So here's our angle again. We'll call this theta bar, and whose hypotenuse is still 1. Theta bar is equal to 14.47. This is a reference angle to the following blue angle, theta. And so the other angle that satisfies this equation is given by theta is equal to 180 degrees minus 14.47. And these are our final answers. We have theta, which is equal to 180 degrees minus 14.47, and we also have theta is equal to 14.47 degrees. In this last example, we want to go ahead and rewrite sine evaluated at tan inverse of x as an expression of x. Let's go ahead and first recall what tan inverse of x is equal to in terms of a geometric representation. So initially, we have that tan inverse of x, is equal to y if and only if x is equal to tan of y. And recall the definition of tan of y is equal to the length of the opposite side divided by the length of the adjacent side. So we form a right triangle whose opposite side has length x whose adjacent side has length 1, then the last side will have length square root of 1 plus x squared by the Pythagorean theorem. And the acute angle corresponding to this triangle is given by this angle here, which is y. Again, the input values of tan inverse of x is the length of this opposite side x here, and the output values are the angles y here. So what we can do is we can rewrite sine evaluated at tan inverse of x as sine evaluated at y. Sine evaluated at y is going to be equal to the side opposite of y divided by the length of the hypotenuse, which means we can rewrite this as x divided by the square root of 1 plus x squared. And this here is the answer.